Hello everyone. We'll discuss about the paper SP2net for generalized zero-label semantic segmentation. I am Anurag and my co-authors are Yongqin, Yang, Professor Zeynep, and Professor Bernt. So let's start with the problem. We aim to solve the generalized zero-label semantic segmentation problem. In this problem, we have seen classes for which the training data is available and unseen classes for which training data is not available. And our task is to perform pixel level classification for both seen and unseen classes during inference time. As an example, we have in this figure a horse, which is the seen class, and we have multiple samples for this seen class, and giraffe, which is unseen class, for which we have 0 samples. So this is during training. During test time, we have both seen and unseen classes, and we are required to predict both of these classes. So in this image, we are required to predict giraffe as well, which was not seen during training. Our major contributions, we have two major contributions. One is superpixel pooling module, and next is the bias reduction loss. From superpixel pooling module, we aim to provide class-agnostic segmentation prior for improving dense features for the unseen classes. And for bias reduction loss, we try to improve the biasness of the trained network on the seen classes, which is a very important problem for the generalized zero-label semantic segmentation task. Now we'll talk about related work in this domain. We have two major related work in this domain, which can be differentiated in two major topics. One is learning synthetic pixel-wise features for unseen classes, and next is using semantic projection to get pixel-wise features for the unseen classes. In the part where we learn synthetic features, we have two important papers. One is ZS3 paper, which is zero-shot semantic segmentation, which was published in Europe's 19. And the next one is CSRL paper, which is consistent structural relationship learning for generalized zero-shot semantic segmentation, which is published in Europe's 20. So both of this paper failed to generate quality unseen class pixel-wise features, and we aim to solve this problem with the help of our superpixel pooling module. Another paper in which we use semantic projection to get pixel-wise features for unseen classes. This paper was published in CUPR 19. This paper also failed to generate quality unseen class pixel-wise features, and we solved this with the help of superpixel pooling method. Also, this paper has prediction bias to seen classes, which we again solve with the help of bias reduction loss. We will see this failures in our qualitative results section. Let's talk about the method. In this part, we show you our architecture. So we have the input image where, in this case, motorbike is the unseen class and person is the seen class. So this image goes through a CNN, which can be any segmentation backbone, such as DPLA v3 or PSPNet. After this image goes through the CNN model, we get the feature maps. At the same time, we also extract superpixels from the image. We use different superpixel methods, including COB, which is convolution-oriented boundaries, or the SLIC method, which is an unsupervised method. Once we have extracted the superpixels, we perform superpixel average pooling on these features. On the right-hand side below, we see superpixel average pooling, which is actually for every superpixel pooling region. What we do is we do average pooling of all the pixel features of that pooling region, and we assign each pixel with a pooled value. Once we have the pooled feature maps, what we do is we project these feature maps onto the word embedding space. And after that, we obtain the logit scores, and we can have different losses on this logit score. So specifically, we have two losses. One is the classification loss, and next is the bias reduction loss. Classification loss is for classifying the pixel, which is applied on the seen pixels, while the bias reduction loss is applied on the ignore regions. So the idea behind the bias reduction loss is that we know that the seen classes should not be present in the ignore regions, and we want to exploit this factor. And we can see that with the addition of this loss, we have improved performance, which we will see in the result sections. So finally, we combine both of these two losses with a lambda hyperparameter, and we see that we have improved performance with the addition of this biselection loss. So let's discuss the result. We have our baseline SPNet model on which we add bias reduction loss and the superpixel pooling. And ZS3 and CSRL are the existing other methods where CSRL is the current state of the art. We have 10 different data splits on which we perform the experiments. So we observe that with both of the superpixel method, that is SLIC and COB, we see improvement of the performance with respect to the baseline. Also, with the addition of the bias reduction loss, we see improvement in most of the cases compared to the baseline, which is SPNet. So this shows that bias reduction loss and superpixel pooling module both helps in improving the performance. Now we'll discuss two ablation studies. On the right-hand side, we have ablation with respect to the segmentation network. On the left-hand side, we have ablation with respect to the different model components. Let's start with the model component first. We observe that on the addition of different model components, which is superpixel pooling and bias reduction loss, we see improvement in the performance, which suggests the importance of both of these components individually. On the right-hand side, where we do ablation with respect to segmentation network, we test with different segmentation network, including DeepLab v3 and PSPNet. And we see that with both of them, when we do superpixel pooling, we see improvement in performance. This suggests that our superpixel pooling method works independent of the segmentation backbone. Now let's see some qualitative results. For qualitative results, we would like to point one example here. Let's look at this example where there's a person, a bike, and a TV. In this case, TV is an unseen class. With the baseline, which is SPNet, we observe that TV is not classified properly. But when we add bias reduction loss, some part of TV is classified correctly. And when we add superpixel pooling, we see that TV is classified totally correct. This suggests the importance of superpixel pooling method and the bias reduction loss with the help of qualitative results. So that was all from my side. Thank you. If you have any questions, you can ask me. Thanks.